For this question, we're asked to find an expression for the nth term of this sequence. Now, what this means is to find a rule which will give you any of these terms. So, for example, this is the first term, the second term, third, fourth, fifth, etc. We know that the next term would be 15. And the reason it's 15 because we're going up in twos. Let me just write that in. So from here to here, I'm adding 2. From here to here, adding 2, etc. Now, if this difference is always the same, we say that this is a linear sequence. And it takes the form of an plus b. N represents the term number. So the first term, second term, third term, etc. And we have to find the a value and the b value. Now the a value is really easy to find. It's just this common difference. So the rule will start off with 2n. And now all we need to find is this b term. And that's quite easy to find as well. So if this was the first term, second term, third, fourth, fifth, etc., what we do is we go back to this 0 term. So in other words, what value would be here? Well, if we're adding 2 each time, all I'll need to do is just to subtract 2 to get to this term here. So this value is 3. So we've got 2n plus 3. That's our rule. That's the expression for the nth term of this sequence. Let's try another one. Let's say I had the numbers 8, 11, 14, 17, and 20. We know we could find the next term easy enough because what we're doing here is we are adding 3. So add 3, again, add 3, and add 3. And because this common difference is the same, we know it's a linear sequence. And again, it follows this rule here. We could be asked to find the next term in the sequence. That would be 23. And to find the rule, we know it's the common difference, so 3n. And then we go back to the 0 term. So what term would be here? We would have to subtract 3. And therefore this number here, this value would be 5, and that is our b term. So 3n plus 5. Now once you've got your rules, it's always a good idea to check them. So what we do to check them is we put the n value in here. So let's take this term here. This is the third term in the sequence, so the n value is 3. If we put 3 in here, 2 multiplied by 3 is 6, plus another 3 is 9. Let's check this term here. It's the fifth term. 2 multiplied by 5 is 10, plus the 3 does give me 13. And if I was to check this sequence down here, let's take this term here. This is the second term. Remember, started here, 1, 2, 3. This was the 0 term. So for this second term, n is 2. 2 multiplied by 3 is 6, plus the 5 is 11. Let's have a look at another example here. So we've got the values 11, 7, 3, -1, and -5. This is my first term, my second term, third, fourth, and fifth terms. I could find this next term by looking at the common difference. Now the common difference this time, I am subtracting 4. Common difference here, again, I'm subtracting 4. Again, subtracting 4. And again, subtracting 4. So my common difference is the same each time. So therefore I know that this is definitely a linear sequence. And it's of the form an plus b. Now the a is the common difference, and in this case it's going to be -4, so -4n. And I just need to find the b term. And the b term I find by going to this 0 term here. So if I'm subtracting 4, what I would need to do here would be to add 4. I'm adding 4 to 11 to give me 15. So 15 is the 0 term, and therefore the rule is minus 4n plus 15. And as before, it's always a good idea to check this rule. Let's take this fourth term here. So n is 4. We put 4 into here. Negative 4 multiplied by 4 is negative 16. Negative 16 add 15 is negative 1. We can check the first term. N is 1. Putting 1 into here. Negative 4 multiplied by 1 is negative 4. Plus the 15 gives me 11. Okay, well, let's have a look at this sequence of numbers here. Again, we'll look at the common difference. The common difference here, we are adding 3. The common difference here, though, is we're adding 5. And then we go to the next one. We're adding 7. And finally here, we're adding 9. Now you can probably tell there is a pattern here, 3, 5, 7, 9. The next one would probably be adding 11. So we can say this value here would be 37. However, the common difference is not the same, and therefore this is not a linear sequence. This is in fact what we call a quadratic sequence, and I'll show you how to do those in another video.